book one, do you want to see it all? 19. And help me out, what was 19? Equals 1 over, oh, I'm sorry, 1 minus sine squared over sine. Okay, so on the identity problems, I think a good way to show it is to put that t in there kind of thing. You don't have to do that, but it make your work very clear and easily followed that the left side equals the right side. Remember, you're not crossing over like we are on equations. You're not adding to both sides. You're not multiplying both sides. You don't do any of that when you're verifying identity. You work with one side, you work with the other side, and you show that the two sides are the same. Okay, so one option would be to get this in terms of cosines and sines, so that one kind of just does that automatically. Cotangent squared could be cosine squared over sine squared, and then this could be 1 over sine. This would be one route to go, wouldn't have to go this route. And then you can do what from here? Yeah, I'm a little nervous to do it that way, but I would invert. If you did that, if you cancel out a sign, as long as that was correct canceling, I would be okay with that. But I would look at it as an invert kind of thing, but it's going to be the same. So I invert and make that sine over 1, and that's going to cancel one of those, which gives me cosine squared over sine. When you do some canceling like that, I would prefer that you then rewrite what's left so that you have something that looks like that. Okay. You know, instead of having all this canceled stuff and then circle it and say that equals that, you know, it gets kind of messy to follow sometimes. So just take care to rewrite it. Homework you might not as much, but if it's a quiz and you know you're getting graded, you know, points for showing steps and so forth, that's kind of important. Okay. Anything else in the book? 28. 28. What was 28?
1 over sine x minus 1 over cosecant x.
1 over sine minus
equals tangent plus
cotangent. Okay. So
was it
it's equals cosecant minus sine.
What did I get there? That's probably why I did it.
That could be one. So you probably looked at the left side on 28 and the right side on 29.
Yeah.
All right. So, any others?
16.
What was that one?
Sine squared x minus sine fourth equals cosine. That's the same thing with cosine.
Like that. Okay. So, one like that, what'd you try? What'd you think of anything?
Well, obviously, like changing the cosine squared or sine squared, but I didn't know what to do with the fourth. I didn't know what to do with
Okay.
how you could, how that translates to cosine.
Right. Anybody else thought?
You literally take sine squared out of one side.
Yeah, that's the key. Take a sine squared out here and take a cosine squared out. Okay, so like you could change this into a 1 minus sine squared, right? And you could change this into cosine squared times cosine squared and make both of them like 1 minus sine squared. You know what I mean? But then you're right. I don't know that gets you anywhere. But what happens here, if you take out a sine squared here, and then you get 1 minus sine squared like that, and you take out a cosine squared here, and you get 1 minus cosine squared like that, then that works pretty nice, because what's 1 minus sine squared? Cosine squared. So this becomes sine squared times cosine squared, and then this is cosine squared, and then that's sine squared, and now those two are the same. Okay. So taking out factoring out. So what are the things we're looking for? Getting common denominators, maybe. Turning things. This would have been turning things into sines and cosines, and then some invert and multiply. Getting a common denominator, which is kind of what you would have done here. on this one, right? When you add two fractions, added or subtracted, getting common denominators is good. And then factoring. I mean, those are really the three big ones when it comes to algebra techniques. Turning into sines and cosines, getting common denominators so that you can invert, multiply, cancel, that kind of thing. Or just invert and multiply so things cancel. And then factoring. Okay, so those are the three big ones to look for. Okay, another one. Anything else? We'll do another assignment very much like this, where we'll do give you some identity ones to practice, and then give you some equation ones as well. Okay. All right. Worksheet. Let's run through the answers real quick. Here's 1 and 2.
Oh. Well, but it's one wrong, right?
Okay.
1 for 3.
Here's 3 and 4 and 5.
Two, 5. That's height.
Okay. Here is 6, 7, and 8. Okay. 9 to 10. And 11. Those are the ones you had to square both sides.
Oh,
Those are the ones you had to square both sides.
I was trying to simplify it.
Whenever,
I mean,
I
I technically did get those two answers, but I got a lot more.
yeah. Okay, so we can talk about why that happened. Okay, so which ones?
Well,
Oh,
let's start with 2.
I don't know if we go through all of them, but I can individually. We have some work time. I can individually talk with you about some if we don't. Number 2.
We can start.
Raise your hand if you want to see number 2. Well, no, that's quite.
Start there.
That's quite a few. All right. So now I kind of an emphasis. Obviously, we did a lot of. I've got another worksheet today that's again some more no calculator ones, and I don't want to. I want to make sure we do a few calculator ones too. There's not as many of those probably on the quiz, but and I always think those are easier, but then we don't do very many of them, and then maybe they're harder because we start doing so many of the no calculator ones that maybe those really all the calculator allows us to do is at the very end do inverse sine or inverse cosine, and then we got to put them in their quadrants, and so forth. So we want to make sure and do some of those as well. But anyway, on this one. What I noticed, there's a cosine squared on both sides, so I can just subtract those, and they're going to subtract away. Right? And so then we end up with a cosine squared and a cosine, one on each side. What do you want to do with that? Subtract it over. Do not do what? Do not divide by cosine. Do not divide by cosine, okay? Because that's the situation. The one where you get in trouble is if you have cosine squared equals cosine and you divide both sides by cosine, right? What you end up with is cosine equals 1. Well, cosine equals 1 would have an answer of what? 0. And that'd be your one answer. But if you subtract the cosine over like this and you factor out the cosine, now you get cosine equals 0 and cosine equals 1. And so now you get pi halves and 3 pi halves as answers, and you get x equals 0. And so there's 3 answers, not just 1. So by dividing by cosine, you lost some answers, okay? So dividing by a cosine, it's not like you never do it, because I think there's one on here where we do want to do that, okay? But not in a case where you've got, where you could subtract them over and do some factoring. That's what you want to do. So those are gone here. So I'm going to move it over to that side. So I got 2 root 3 cosine squared plus 3 cosine. Now I can take out a cosine, and I get 2 root 3 cosine plus 3, I think. Did I do that right? So I have either cosine x equals 0, or I have this, 2 root 3 cosine plus 3 equals 0. So that or that has to equal 0. So this would be 2 root 3 cosine equals negative 3. Divide by 2 root 3, I get negative 3 over 2 root 3. And what can I do there? I can multiply root 3 times root 3. And that gives me cosine x equals, what would this be? Negative root, oh yeah, because this is going to be a 3 down here, which is going to cancel that 3. So I'm going to get negative root 3 over 2. So it didn't look very good for a while, but at the end it ends up being nice. Okay, so for this one, cosine is 0. That's going to be at pi halves and 3 pi halves. Okay, right? That's where cosine is 0 in the unit circle there and there. Okay, and then negative root 3, that's going to be your, this is cosine. So cosine is negative in those two quadrants right there. So pi 6 is our reference. So that'd be 5 pi 6, and that'd be 7 pi 6. Okay, so there's our 4 answers. All right, what else? Anything else on the front? Okay. On 5, you would have, I got a sine, I got a that, I got a that, I got another sine. Oh, well, geez, I can subtract those signs. Okay, those will just go away. Okay, so now I got 0 equals this. What can I do with that? Take out a cotangent. And so now I got cotangent theta, and I got root 2 plus 2 sine. So now I got cotangent equals 0, or I've got root 2 plus 2 sine equals 0. So 2 sine equals negative root 2, sine equals negative root 2 over 2. So that's an easy one here. Let's do that one first. So sine's negative down here. That'd be what, a pi fourths? So what is that? 5 pi fourths and 7 pi fourths. So that would be those two. And then cotangent is 0. How did we say to do that? Cosine over sine. Cosine over sine is 0. So cotangent 0 is basically when is cosine. A fraction is 0 whenever the top is 0. So cotangent is 0 when cosine is 0. And cosine is 0 up here at pi halves and 3 pi. Okay, so factoring was big on several of these. Okay, did I hear 6 a lot? See, the thing on 6 is you have 4 terms here. Well, gosh, this worksheet's happening a lot. You see how those would cancel out? That's like 3 problems in a row. So the problem looks a lot worse than it is once you get that out of there. But even if that didn't happen, you still have 1, 2, 3, 4 terms that all have cosines in them. You can move everything over and you can factor out a cosine, but now 2 of them are gone, so it's going to end up kind of being the same thing. So I'm going to move that over there. So I got 2 root 3 cosine plus 3 cosine cosecant. So I'm going to take out a cosine. I get 2 root 3 plus 3 cosecant. So cosine x equals 0, and 2 root 3 plus 3 cosecant equals 0. So 3 cosecant equals negative 2 root 3. Cosecant equals negative 2 root 3 over 3. right? Which looks weird, but that's okay, because it's cosecant. What do we have to do now? We have to flip it, right? Remember, that's what we do next. We say, okay, well, if cosecant is that, then sine is this. Well, we had that a little bit ago, right? We're going to have root 3. So these root 3's will be 3, which will cancel that. So it's going to be negative root 3 over 2. So it's going to be sine equals negative root 3 over 2. So whenever you get down and you get cosecant equals, flip it, and that'll be sine. Okay? And so where's cosine equals 0? Seems like we've had that a lot. Pi halves and 3 pi halves. And sine is down in the fourth quadrant with a pi 6 reference. No, that's sine this time. That was cosine last time. So that's a pi thirds reference. So 4 pi thirds, 5 pi thirds. Okay. All right, what else?
I think I'm gonna do number 1. It's time to get one of the solutions.
Number 1?
Yeah.
Oh, too late. We're over down the back page. You only got one of the 3?
Yeah.
Did you divide?
No.
So did you turn this into,
1 minus sine squared.
well, and there's a negative on it.
Well, I put,
Yeah, so then it ended up being sine squared minus 1. Or moved it over here.
yeah.
Yeah, that's fine. Okay, so move it over here. So add this over to this side, which would be cosine squared, and then make it 1 minus sine squared, and then minus a sine squared, and then plus a sine, and that equals 0. So this would be, I don't like those negatives. I'm going to make everything. So that'd be negative 2 sine squared, but I'm going to make that 2 sine squared, and then this would be a minus sine, and then this would be a minus 1, like that. Did you get to that point?
Yeah.
Is that what you have? Right, all I'm doing, I'm adding those up, that's negative 2, but I don't like my leading coefficient negative, so I'm dividing everything by negative, so switch the sign. So now it's a FOIL, I think, isn't it? So we're going to have 2 sine, sine. Is that what happened? You see what happened? There's going to be a minus, there's going to be a plus. So sine equals 1, that's going to be your pi halves. And sine equals negative 1/2, that's going to be your 7 pi 6 and 11 pi 6. Okay? So, yeah, do the FOIL. Now, it's possible one of those could be no solution, right? And then you would just have one answer, maybe, or 2 answers. Okay? All right, what about those last ones? We'll do one of those where we square it. 11, okay? So, and here's how you figure this out, because you get, so let's say, okay, we can add the 2 sine over here. So now we got cosine minus 1 plus sine equals 0. Is that what we'd have? And so let's talk about this. So if you don't have a sine squared or a cosine squared where you can sub it, you don't have anything that can factor. So basically this is going to come up when you have a sine and a cosine to the first power, both of them. Now, and one of 2 things is going to happen if you get a problem like that. So if I get a 2 sine x equals, now this wouldn't be a problem that would work nice. Let me make that a root 3. There we go. Let's make that a root 3 sine x equals cosine x. Okay? So if I had this problem, then I would not square both sides, right? What can we do to both sides of this? Here we could divide by a sine or divide by a cosine. It's going to end up being the same either way. But in this case, if we divide by a sine, we now get root 3 equals cotangent of x, right? Cosine over sine. So sometimes when you have a sine and a cosine, but no squares or anything, if you can isolate it so you just have a single sine on one side and a single cosine on the other side, you can divide by one of those and turn it into a tangent or a cotangent. And that can be a good strategy. Now, you did lose some solutions. You lost the solution where sine is 0. Well, that would be at 0 and pi. And so you have to be aware of that you may have lost a solution. But in these kind of problems, it's not going to matter. It's not going to be a solution to the original. If you put 0 into here, sine of 0 is 0, cosine of 0 is 1, they're not going, those two sides aren't equal. You put a pi in there, it's not going to work. It's the problem I did on the front side where you got to be careful. If you got a cosine squared and then a cosine over here and you divide by a cosine, you've lost a solution. Because you could have subtracted it over, factored, and done stuff that way. But here we have no option. And so divide by sine is actually going to be okay here. Now, cotangents root 3, what would we do? We turn that to a tangent and make it 1 over root 3, right? And then 1 over root 3 that's like 1/2 over root 3 over 2. That's like sine is 1/2. That'd be a pi 6, right? This would be a pi 6. And that would be in the first quadrant, pi 6, and down here, 7 pi 6, right? Because tangent's positive in the first and third. So if we had just a sine and just a cosine, and we were able to isolate those on each side, we could divide by one of them, turn it into a tangent. But that doesn't work here. That doesn't work here because, see, because of this plus 1. Or this minus 1, right? So I could move this sine over to this side, but I'd still have that. So there's no way I can divide this. Like if I went and did, okay, cosine minus 1 equals negative sine, I can't divide this by a cosine and get anything nice to happen. I get a tangent. Here I could split this apart and get 1 minus cosine. I don't get anything nice to happen like I did up here, okay? So when you get a sine and a cosine, and that's all that's in it, you can't convert them into anything else because they're not squared. Maybe it's going to be that thing where you can divide and get a tangent in there. Or it's going to be this thing we said the other day where you're going to square both sides. Okay, and so that's what we have here. Okay, so let's go ahead, and it doesn't matter which one we move over. Let's just move the sine over. So now we're going to square both sides. Now remember, we said when you square both sides, you might get an extra solution. So here we're going to get cosine squared minus 2 cosine plus 1 equals, and then this is going to turn into sine squared right here. Okay, now we're going to remember that this is our original problem right here. Because this is how we're going to test to see if we got any extra solutions. Okay? All right, now we see what can we do with this sine squared. Make it be 1 minus cosine squared, right? And then we got all that. So now what can I do? I can add that cosine squared over there. Right? I can add this cosine squared over here. I'm going to get 2 cosine squared. I got my minus 2 cosine. And then what happens to the ones? They cancel out. And now I just have 0. Okay, so I thought I was going to end up with a FOIL. It looked like I was going to get a FOIL situation, but then the ones canceled out. So now what do I have? Now I factor out. So now I'm going to factor out a 2 cosine. I get cosine minus 1. So now I get 2 cosine x equals 0. And I get cosine x equals 1. So where does cosine x equal 1? That's at where? 0. Right? Cosine x equals 1. That'd be at 0. And divide by 2. I get cosine x equals 0. Where does cosine equal 0? Pi halves and 3 pi halves. Oops. Now we should test those. So see how there's 2 answers here? I got 3. Okay. So let's try pi halves. So what's cosine of pi halves? Cosine? 0. Cosine is the answer. Cosine of pi halves is 0. Minus 1. Sine of pi halves? 1. Right? So I got 0 minus 1 plus 1. That's 0. Okay, so pi halves work. Let's try 3 pi halves. Cosine of 3 pi halves? Negative. No, 0. Cosine of 3 pi halves is 0. Minus 1 is negative 1. Sine of 3 pi halves? Sine is negative 1. Negative 1 plus negative 1? Negative 2. not 0. So 3 pi halves doesn't work. Okay? And then try 0. Cosine of 0 is 1. Minus 1 is 0. Plus sine of 0 is 0. 0 plus 0 is 0. So 0 and pi halves work, but 3 pi halves did not. Okay? So we had to check. So and that's only when, so you make a note to yourself, that's when you square both sides, you might get extra solutions. When you square both sides, you might get extra solutions. When you divide both sides by something, you might lose a solution because you can't divide by 0. So if you divide both sides, you've lost any place where sine is 0. So where is sine 0? Well, sine is 0 just at 0 or at pi. Well, that wasn't one of our solutions here. So, right, so we didn't, and if we plug it back in, if we plug 0 in, we don't get those equal if we plug pi. So we didn't lose anything. But that's the only time we would divide by a sine or divide by a cosine is when we're trying to get this tangent, right? Because we have no other option. But we don't want to divide by sine or cosine if it's because it's squared or cubed. We want to get rid of some of them. There we move everything over to one side, get 0, and we factor. Okay, so 12 would be very much the same thing. So you can try that. Okay, all right. Let's try a few here. Just a couple of different ones that I've got here. So this is one of those with a 3 in it. We didn't really have any of those on this worksheet, so I want to review that idea with you here. So let's go ahead and try that. 0 to 2 pi. Theta is between 0 and 2 pi. So anytime I write it in this notation, I'm talking about theta is between, or x, or whatever the variable is. How many answers?
6.
All right, so cosine, get cosine by itself is -1/2. Cosine's negative in the second, third quadrant. Pi thirds is our reference angle for cosine being 1/2. So we got 2 pi thirds and we got 4 pi thirds. However, we got to go around 3 times, right? Theta is between 0 and 2 pi. 3 theta is between 0 and 6 pi. So that's 3 times around. So 2 pi thirds, you go around another 2 pi, which would be 6 pi thirds, right? So that's going to be what? 8 pi thirds? And then you go around another 6 pi thirds on this one, that'd be 10 pi thirds. I see how I'm doing that, right? What I'm saying is we got to run 3 times. Well, this is 2 pi thirds, and I got to go all the way around to it again. Well, that's 2 pi. Well, that's 6 pi thirds. So I went from 2 pi thirds and added on and got 6 more pi thirds. That's 8 pi thirds. And this was 4 pi thirds and added on a 6 pi thirds. Okay, and then I keep going. So on this 8 pi thirds, I'm going to add another 6 pi thirds. So that's 14 pi thirds. And on this 10 pi thirds, I'm going to add on another 6 pi thirds. So that's 16 pi thirds. Now again, what is that? That's 5 1/3 pi, right? That's 5 1/3. 16 over 3 is 5 1/3. I can only go up to 6 pi, right? So I'm stopped short of 6 pi. So that's why I have to keep going, right? Because 3 theta is between 0 and 6 pi. So I have to get all the ones going around it. And then we do what? Divide everything by 3, which puts 9s on the bottom. Okay? All right, now, what we haven't done, and we might do tomorrow, but it would be, again, maybe one time on a problem. Well, we're definitely going to have somewhere we have to do all solutions, right? Give all solutions, the plus pi n, plus 2 pi n, that kind of thing. Okay? But what we haven't done yet is do that with a problem like this, where it had a 3 theta on the inside. So far, we've only done that when it was 0 to 2 pi. Okay? All right, so let's give that some thought. So let's take this same problem, except this time, the directions are just find all solutions. Just jot down what you think you would do from this point forward right here. All solutions. So we're going to have the 2 pi n kind of business going on. Okay? All right. Did you get that far? Doesn't that make sense? I mean, it's the same thing we were doing, right? You draw your picture. It's in the second and third quadrants. It's going to be 2 pi thirds, but you could go around and around. So 2 pi thirds plus 2 pi n. And it'd be 4 pi thirds plus 2 pi n. But that's not theta. That's what? That's 3 theta, right? So same thing. You take off the cosine. You do the inverse cosine, -1/2. That would be 2 pi thirds and 4 pi thirds, but then we would have to go around and around and around and around. But that's 3 theta. So what do you suppose you would do? You would divide everything by 3. And by everything, don't you mean both terms, right? You're going to divide both terms, kind of like distributive property. You're going to divide that by 3, and you're going to divide that by 3. So it's really no different than combining the two things we've already done in these problems. We already know that when we find our two angles, whatever quadrants we're in, we know we have to set that equal to 3 theta, and then we know we have to divide by 3. So if you're doing all solutions, you just will tack on your 2 pi n right away when you first do the 3 theta, And then when you divide by 3, you'll have to divide everything with 3. And so it would look like that. Now, the only reason, well, I show you that because in case that would be on there, if that would happen to be on one of your all solution ones, it's really not adding too much to the thing. The book, I think the book actually teaches it this way. I don't know if any of you had looked in those examples when you were doing the 3 thetas and so forth, or the answer book might have shown this too. You know the one we just did that had 6 answers? One way that some people do those, when you get to one that's here that's 0 to 2 pi, instead of writing this like I like to do, like the 0 to 6 pi and go around 3 times, what they do is every time they get a problem that has something inside like this, they do this. They do this and then write this. And then they just start doing what this says to do. They just say, okay, well, let's take 2 pi thirds, or excuse me, 2 pi ninths. Let's take 2 pi ninths, and if we're supposed to only get answers from 0 to 2 pi, let's get 2 pi ninths, that would be 1. Then let's add on 2 pi thirds, which would be what? How many pi ninths? Would that be 6 pi ninths? Right? So let's add on 6 pi ninths to that. What's that? 8 pi ninths. And then let's add another 6 pi ninths on. 14 pi ninths. And now let's add another 6 pi ninths on. What's that? 20 pi ninths. Oh, wait a minute. I just went past 2 pi, didn't I? Because that 2 pi would be 18 pi ninths. So I just went past 2 pi, so I would know to stop. And then same thing here. I'd have 4 pi ninths. And then I want to add on 6 pi ninths. That'd be 10 pi ninths. Then I want to add on 6 pi ninths. That'd be 16 pi ninths. And then add on another, that'd be 22. Oh, that's too much. And so I'd have 1, 2, 3, 1, 2, 3. So, it's a thought. If I give you one with the 3 theta and say go 0 to 2 pi, if that other way has been confusing for you, I saw some of you as we were doing it were writing, like maybe you were changing your answers. Maybe this makes more sense. Maybe this makes more sense. Maybe you'd rather do that. So the way the book teaches it, anytime you have a 3 theta or a 2 theta or something like this in here, is to write it like this, then divide, and then use this to generate your extra answers until you get over 2 pi, and then you stop. Okay? So, thought. If the question did say do all solutions, then you would just stop with the blue answers. And then that. Okay? All right. Try this one. First, let's try this one, no calculator. Do this one, no calculator. answers? How many answers that you could actually find? I'm going to have to get extra red page. All right. Oops. Okay, what are you going to do first?
Somewhere in between 1 and 20.
What are you going to do first?
Pull out a 1 over cosine. Okay, well that's what I did.
Wow. Yes, actually.
That's what I did.
Sit down.
Well, okay, before you hurt your shoulder patting yourself on the back, it would be an awful way to do it, but it would not be incorrect. Okay? Anybody else have a thought? Yes. Change secant squared into 1 plus tangent squared. Ah, boy, we got to study our identities. Okay, well, that's not the part I thought we were going to have trouble with. So, yes, change the secant squared to 1 plus tangent squared. That is right, isn't it? Isn't secant squared 1 plus tangent squared?
Yeah.
Okay, you had me nervous there for a minute. Okay, yes, secant squared is 1 plus tangent squared. Changing everything into sines and cosines can be a strategy when you're solving equations. I just don't think it's that often you use it, probably. So Seth, yeah, you could make secant squared 1 over cosine squared, make tangent sine over cosine, right? That's what you did, and then you pulled out a 1 over cosine.
Yeah.
But did it take you anywhere?
I think
Nice.
that would go.
Yeah, it's not very nice.
I thought 1 was no solution.
It's not no solution, but let's keep going with it. Okay, so now I've got tangent squared, I got minus 2 tangent, and if I subtract the 4 over here, I get minus 3. Wouldn't that be true? And then what? And now FOIL. Tangent's minus 3, tangent plus 1. Right? So now you get tangent equals 3 and tangent equals negative 1. Right? So what about tangent equals negative 1? Well, tangent is negative in the second and the fourth. When does tangent equal negative 1? What's the reference? Pi fourths, right? That's one we should know. Pi fourths, that's 3 pi fourths, and that's 7 pi fourths. So when I was asking how many answers that you can actually find, that was what I was getting at, is those two we can actually find. But do we know when tangent equals 3? That's not one of our numbers. Now, we haven't run into that, and I'm not going to make you do that tomorrow on the quiz. But that doesn't mean, just because I be on the quiz doesn't mean it's not worth talking about. It's not something we should think about. So what we often do with one like that is we simply do the arc tangent or inverse tangent to the other side, and we just write arc tan of 3. Now remember, on your calculator, when we come back from lunch, we'll do this with a calculator. If we were going to write arc tan of 3 in our calculator, it would just give us one answer. There's another answer, isn't there? I mean, where does tangent equal a positive? In the first and the third. We don't know what this angle is. We're just calling it arc tan of 3. How would we get the other one?
180.
Arc tan of 3, no, we're in radians. Arc tan of 3 plus pi. And we would just write arc tan 3 plus pi. We'll talk about more when we get back.
Oh, I got all the way to the top right
It is. It's very important. I'm not minimizing the importance of this debate at all. No, you're right.
No, it's not
This is
important.
like number one priority in my life.
Well, I get it. You're not going to be able to focus
You
on
went to like
each
4
trade,
tables at
right?
once, and it was like, it's a hot dog, is there? You can hear the whole table.
Yo, we're split 2 and 2 though.
All right.
But we got the teacher, so we win. I'll say hot dog.
I got my food.
All right. Where are we picked up? We just got a couple more things to do real quick, and then we can get going. Of course, I said that the other day. We had like 2 to do, and then it took 30 minutes. So this right here, not going to have to do this on the quiz, but just understand how in a no calculator situation, you could write the answer as just arc tan of 3, right? That means the angle whose tangent is 3. But remember, that's just one angle, just like when you do on your calculator, you do inverse tangent of 3. It's going to give you one angle. It'll either be in the first or the fourth quadrant with tangent, right? Positive be in the first, negative be in the fourth. And so there's this unknown angle, we call it arctan of 3 up here. There'll be another one down here. Well, that's pi units. We don't have a reference for it, right? We don't have a reference for it. So I guess other than arctan 3, so this would be pi plus arctan 3. Okay, pi plus arctan 3. So you could write it like that. Now, let's imagine this was a calculator. So everybody get your calculators out. So let's imagine this very same problem. Okay, now this is where it would be on the quiz tomorrow, right? This part could be on the quiz tomorrow. So same problem. Change your secant squared to 1 plus tangent squared. Get it down to here. FOIL. Get to here. And now the directions would have been 0 to 360 degrees. So you're in degree mode, right? And we go ahead and we do inverse tangent of 3. And what do you get?
71.
70. Well, let's go to the nearest hundredth. 5,7. So there's one answer. So that's going to be 71. But then you still need to go to your drawing. Still need to go to your quadrants. So the calculator is just going to give you that one angle. Okay? And it might be a reference angle, it might not. Remember, if it was cosine and it gave you 120 something, well, we're going to get that here in a minute, I guess, with, well, no, we're not going to with tangent. But, well, yeah, I guess we will. Where you have to figure out what that reference is. Okay, so that's 71.57, what's the other one?
251.57.
251.57, because that's going to be over here in the third quadrant, because tangent is positive in the first and the third. Okay? Now, go ahead and do inverse tangent on the -1. Now, we do know that one, but let's just say, since it was a calculator and you'd already done this, you probably aren't thinking of it. You're just thinking, okay, let's do inverse tangent. And what do you get? -45. Now, we know tangent's negative in the second and fourth, so we understand that it gives us -45, but what are we going to write? For that one, we're going to write 315, and then what are we going to write for the other one? We're going to write 135. Okay? So the calculator gives us one angle to get us started in a quadrant. It might or might not be the reference angle. We might have to get the reference angle ourselves. In this case, it gave us the reference angle, but we'll have to get the rest. So 180 minus 45. And then here it would be 360 minus 45, and we would get those two. So there would be our four answers if this was a calculator, right? We could get them.
So how do you know if it's reference or if it's...
Well, you just draw it. Whatever the calculator gives you, you draw. Okay? So if it gives me -45, that's down here, right? So the reference, remember, is always right here like this. So I know my reference is 45. If it gives me 120, like on a cosine one, so I know this is 120. Well, that's not my reference. What's my reference? 60. So once you draw it, you'll know where your reference is. Right. Okay? And if it was cosine, you'd get this from a negative. So let's say, well, let's just do that on your calculator. So let's say do cosine, and let's say it was a calculator problem and we had this, right? So go ahead and type that in your calculator. Inverse cosine of -1/2, and it gives you 120, right? So if that happened, if this was a calculator one, so even though that's one we wouldn't need a calculator for, we could go ahead and do that. But we could say, oh, cosine 1/2, that's a 60-degree reference. That would be in the second and third, we would just draw it. But if we use our calculator, it gives us 120. So we would draw it and we'd say, oh, okay, 120, well, that's 60. That'd be 60, so that'd be 120 and then 240. And there would be our two. Okay? So yeah, so when we have the calculator, we do have to keep that in mind. Okay, do this one real quick. Do this one real quick on your calculators. So how many answers are there?
Wait for it.
Four.
Plus minus.
You sneaky.
Plus minus, right? Well, it's better to be sneaky now than tomorrow, right? And it might be, it could definitely be on there tomorrow, right? So when you do the square root of both sides, you got to put the plus minus. So that's going to be 4 different answers. Okay, all 4 quadrants. And am I right there? Is that what you're getting? 48.59. Okay, but it's going to be in all, and so that is first quadrant. So that's our reference when we draw it. We can see that's our reference for all of them. So one of them is going to be 180 plus that, so 228.59 will be 1 for sure. Second quadrant, I don't know, what is that, 131.41, the round to 41. And the other one is 311.41, would that be the other one? Okay, so 360 minus 48.59, 180 plus 48.59, 180 minus 48.59, and then that. So those would be our 4. So just, yeah, remember when you square root both sides, plus or minus, and that goes for no calculator or calculator. The one we did that was no calculator, I think we had like a sine squared equals a half. And when you do the square root of that, square root of a half is 1 over root 2, which is root 2 over 2. Okay, and it's plus minus. Okay, so just remember doing that, but also with the calculator. Okay, so don't forget that. All right, last thing I wanted to do is this story problem right here. This is actually on your worksheet. So what I've got here is I've got a worksheet that's got some. And if you want to, get a picture of the answer sheet up here before you go, before you go today, I've got that. So this has just a variety of equations, some of them in degrees, some of them in radians. When it says give an exact solution, they're talking about no calculator. So the first, down to through number 12, those would be no calculator. 13 and 14 would be calculator. Okay, so where it says a tenth of a degree. So you got some in radians. The first one say find all solutions. I would assume that would be radians. Tomorrow, if you get one that says all solutions and it doesn't say radians or degrees, assume radians. Always assume radians. Okay, always assume radians. But when it says 0 to 360, obviously that's degrees. Okay, the story problem. Let's go through the story problem. Okay. So the function y equals blah, 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 models the altitude of a ball t seconds after it was hit at an angle of theta degrees. So now here we did a couple story problems where we were in radians, and I told you I will say in the problem to remind you if you need to be in radians. If it's story problem, you need to be in radians. This one obviously is an angle. It says degrees right there, so we know we're in degrees. Determine to the nearest tenth the measure of the angle at which the ball was hit if it had an altitude of 40 feet after 1.5 seconds. So what do you think you're going to do? Plug in what? Yeah, picture maybe. Hitting the ball. Here's theta, right? That's hit at, whatever. Plug the 40 where? Where? Right there. 1.5 for t. Right? So this one's a little simpler than I think the one we were doing before. The other ones we were kind of, there were several. We had to kind of think of a graph, the equation. We could solve it. We would still solve it, but there'd be multiple answers. We'll have to think about that on this one if there's going to be multiple answers. And I don't know, this would be a calculator one. What's 16 times 1.5 squared? Exactly. 36. Okay. So 1.5 squared times 16 would be 36. So, right, pretty straightforward here, right? Once you get that part figured out, that you plug a 40 in for the y, you plug a 1.5 in for the t, now you're just going to do what? Add 36. And then divide by 122. and then we're gonna do an inverse sine. So 76 divided by 122, and then an inverse sine. What do we get? How much? 80, 38. And what did it say? Nearest 10th. 0.5. Now, that would be in this quadrant. Would it make any sense to have one in this quadrant? 141. No, you're not going to hit a ball at an angle of 140. That'd be going backwards. Foul ball. That'd be a foul ball. That'd be a foul ball. That would, you would swing this way and it would go back that way. Right? So I guess, but doesn't say that, yeah. And so, yeah, bonus points if you put in there. If it was a foul ball, then it would be okay. No, it says that it could. You could have a foul ball that go 40 degrees, right? 1.5 seconds. All right, so we would just look for that answer there, 38.5 would be the only answer. Makes sense. All right, now, so this is the worksheet that I have up here, and then here are some more identity ones. You can put them on the back of the worksheet if you want, or in your notebook, whatever. But that's just a few more on that identity page. Okay, and that's it. I mean, that's the thing. The equations, some will be all solutions, some will be radians 0 to 2 pi, some will be degrees 0 to 360, some will be calculated. Okay, all the identity ones will be on the no calculator part. Obviously, the calculator's not going to help you much there anyway. Okay, so that's pretty much it. Maybe a story prop, maybe a few of the, or one or so of the little stranger ones, a 2 theta or something like that in there. I do have, so sitting up here, I got the answers to, this is side B, so I got the answers to that worksheet I just gave you. I do have another stack of worksheets that are like the ones you did today. There's 12 problems, they're all no calculator, they're all 0 to 2 pi. That's totally optional. If you want to grab one as extra practice, you can grab one. I've got the answers to that. Front and back right here. If you would want, you think, hey, maybe I better have some extra practice and try those, you can take that. Okay? But otherwise, the worksheet I gave you are those problems. And then quiz tomorrow. And look at that, actual time to work. Not a minute and a half. Yeah, to work or to argue about high notes.
I have another one though.
Oh,
Is a cupcake without frosting a muffin?
The muffin needs to contain some
It doesn't need to. You have chocolate chip muffin.
Chocolate chip muffin.
That's not. This is the muffin is.
I cannot lose. You guys cannot prove me wrong in my own mind.
No.